In this episode, I have a Sony M677. This is a microcassette dictating machine that has two speeds, 1.2 centimeters and 2.4. This is a capstan drive microcassette, not to be confused with the other mini system, which was called a mini cassette. This one does not operate. There's no tape movement. It's probably a belt that's shot. Let's take a look at it and get it going. No tape movement on this unit. I don't even hear the motor on this one running. So we'll start out by removing the batteries, and there'll be a screw in the battery compartment as well as 3 other screws on the back, and then the back cover should lift off. And on most of these units we have to remove the circuit board to access the motor and the flywheel. Two more screws to hold the circuit board in place. On these ones there's not a lot of room to work on them, so it's a little easier if we pull the speaker and disconnect the motor, just so that the circuit board can be flipped out of the way. It's pretty tight in these units. Now when I flip this board over, you will see no resistors at all on this. There's actually resistors there, but there are no physical resistors. Okay. So what we have here is we have a belt that's got come all apart, got stretchy, and has wound itself around the motor pulley here. So what we need to do is we need to find a suitable replacement belt. This is one of these really thin ones. I may have one. We'll work on this and get this little unit working. The person that owns this thing, they've got some recordings that they want to hear that are on these tapes. So I won't be doing any recording on these, and I won't be playing these tapes back once I get this thing working, other than maybe a second or two, because they're personal tapes of somebody who wants to actually hear them. So I won't be able to do a test recording, but I will be able to do a test playback. I'm just going to remove the 2 wires to the motor here so that I can swing the circuit board out of the way. This way I can flip the board out of the way. And we'll find a belt that will replace the one that's on there. You notice on this circuit board here, these are all resistors here, right, that are just painted onto the board, these black marks. These are actually the resistors. This is truly a printed circuit, where they literally printed everything on the circuit. Surface mount ICs on one side, and a couple of capacitors which are through hole, and a couple switches, but all of the resistors on here, they're just all painted onto the board. And this is actually painted. These lines here are not actually copper, you can see them. These are actually conductive ink. So if that gets damaged, then there's really not a lot you can do. Well, I guess you can use the same conductive ink to go over it, but yeah, we're not ever designed to be repaired, that's for sure. Okay, I've got another belt here. It's not quite as fine as the other one, which again, for something like this, is probably not important. It's more of the size of the belt, whether it'll fit in the groove, and whether it'll provide enough torque. And I think that should work just fine. As again, this is just a voice quality recorder, so we're not talking something that's going to be producing hi-fi sound. So it's not like the belt is really all that important. As long as it turns, then it should be okay. Just have to make sure that all these little switches line up. Tape speed. Okay, now that the unit's back together, I've got it loaded with one of my own tapes. This one's actually out of my answering machine. So I recorded this little segment on my answering machine. It's at 2.4 centimeters per second because I want to make sure that the speed is correct. So let's take a listen to a recording that I made on my answering machine, and then we can make a recording on this, and then we'll check the other tape out. But I can't, obviously I can't let this tape play for more than a few seconds. So here's a recording that I recorded on my old answering machine at 2.4 centimeters per second. So this will determine whether this is running at the correct speed.
Yeah, okay, we'll just do some recording here. We'll see how this records. This machine records at the higher speed. I think this is 2.4 centimeters per second. So we need to do a recording so that I can record onto this thing.
So I've loaded a tape. I'm going to make a recording. This is a blank tape. I'm going to make a recording on the machine. We'll do it at both the 2.4 centimeters and the 1.2. Oh, by the way, there's a speed adjustment underneath here if you need to adjust the speed. This little cover comes off, and there's a little sticker. But underneath here, there are speed adjustments for the 2.4 and the 1.2 centimeter speeds. That's where the speed adjustment control is. I'm going to make a recording at 2.4, so here we go. So now I'm recording on this unit. And I'll just record my voice here for a few seconds, and then we'll switch it down to the 1.2 centimeters speed. Of course, the sound quality in that speed is probably going to be pretty pathetic. But here's the 2.4 speed, and let's switch it down to 1.2 right now. Okay, now we're operating at the 1.2 centimeter per second speed. And I've been noticing that my camera keeps slipping on the tripod here. I guess I'm going to have to do some work on that. Every time I set it up, it seems to move. Anyway, this is a recording at the 1.2 speed. Let's play the tape back. So I'll rewind the tape. We'll switch it back to 2.4 and play the tape back.
So now I'm recording on this unit. And I'll just record my voice here for a few seconds. And then we'll switch it down to the 1.2 centimeters.
There's also a fast playback speed.
Of course, the sound quality in that speed is
Probably going to be pretty pathetic.
Got a fast playback mode here.
But here's the 2.4 speed, and let's switch it down to 1.2 right now. Okay, now we're operating at the 1.2 centimeter per second speed. And I've been noticing that my camera keeps slipping on the tripod here. I guess I'm going to have to do some work on that. Every time I set it up, it seems to move. Anyway, this is a recording at the 1.2 speed. Let's play the tape back.
Okay, so that was a recording made on this unit at both the 1.2 and the 2.4 speeds. Looks like this unit is functional again. So say the eject doesn't work properly because the little plastic clips here are broken. But this is a micro cassette recorder, used one of the smallest of the micro cassette tapes. There was also a mini as well. The mini cassette did not have a capstan drive. This one here has a capstan and a pinch roller on this. But old technology, client that owns this has some tapes. I'm not going to play their tapes, although their tapes sound actually worse, because I think when the tapes were recorded, the belt that was in this thing, if it was made on this machine, was probably slipping. So I don't want to play their tapes because it may have some personal information on there. I might just play it here for a couple seconds.
that's how they're going to judge cascade work. That's what they want to hear.
So I don't want to play that, but we made a recording. It sounds fine. So I think the higher flutter on this, the tape that they had with the unit, is probably because the machine itself, when the recording was made, either the belt was slipping a bit or it was made on a different recorder. But sound-wise, it's recording and playing fine. Self-recordings and recordings. I did a test recording on my other machine as well. I didn't and it plays fine as well. I made a recording on my my answering machine and on this tape and played it back, and it sounds fine. Anyway, that's it. Replace the belt on a microcassette recorder and a Sony M677V. Thanks for watching. We'll catch you in the next one real soon. Bye for now.